So this one is June 2023, Unit 6 of IEL Physics. Every session we'll do a question or two, depending on the question itself. In the first question, and you have to answer all the questions, like you don't have options. You have to answer all the questions. So a water tank is shown below. The depth of a water in a water tank is kept constant. So the depth is not changing here, like this depth. Like this depth is not changing. Water inlet is there and water outlet is there. The height edge can be adjusted to vary the volume flow rate of a water moving out. Like we can adjust this height, we can change this height. We can reduce this height or we can increase this height. That can be changed, but the depth of the water is not changing here. Okay, that is constant. Describe a simple method to determine the volume flow rate of a water moving out of the tube. Like volume flow rate means like how much the change in volume is there in a unit time. That is a volume flow rate. So we want to determine what is the volume flow rate for this. For those who just joined now, we were starting, this is June 2023 Unit 6 paper. Every session we'll do a question from Unit 6. So if you want to measure the volume flow rate, it's like the change in the volume and the time. Okay. So the things what we have to measure, and it's of 3 marks. So we have to measure the time, record the time, the simple experiment to determine the volume flow rate. Whenever something is related to rate, it means it is refers to time, like per unit per second. So we'll record the time by using stopwatch. Then we'll record the volume of water flow out. How we can measure the volume of water which will flow out? By, like, we can place a measuring cylinder there or we can place a beaker there. And then the volume flow rate will be 1 mark is for writing a formula. Volume flow rate is the volume of the water which flow out divided by time. So we'll know how much volume of water will flow every second. In the next part, the student connected the tube. The student connected the tube to water flow device as shown below. You can see like water from the tube is moving and then paddle wheel is there and that is a magnet is there and a coil. So when this will rotate, there will be a change in magnetic field and the change in magnetic field will induce EMF or a current. A magnet is attached to a paddle wheel. As the water flowed through the device, the paddle wheel rotated, making the magnet moving past the coil. The student connects the coil to an oscilloscope. So oscilloscope is used to determine the, you can use it to study the waveform or the voltage produced or the current. The oscilloscope main purpose, like we can input with any like mic is there or any electrical device is there and it will give us the output on the screen. And one box is refers to one division. The horizontal axis is representing the time axis. So horizontal axis is the time axis and the time scale was set 50 millisecond per division. Means one box, this one box is representing what? It is representing 50 milliseconds. So 15 to 10 power minus 3 of the second. Calculate the frequency. So if you want the frequency, frequency is reciprocal of the time period. So what we'll do, we'll determine the time period What is the meaning of a time period? The time period means time to complete one vibration or one oscillation. Like, for example, if we have a wave, the total time it takes to complete one crest or one trough, that is a one wave. So the time it takes, that's called a time period. Or if we have like, if we take from one crest to another, that is also one wavelength. So the time from one crest to another crest, that's also refers to a time period. For accurate result, instead of taking two, like instead of taking one, you can also take two. So it's up to you. Like if I take from one peak to another, I can take from one peak to another, or I can take like for one crest to another crest. This part. Like one crest to another, or I can take one crest and one trough. That will give us the time period. And after getting it, or you can measure the time period for two complete vibrations or three complete vibrations, and then divide that by the number of vibration, you get time period. Like you get the total time. After getting a total time divided by number of vibration or oscillation, you get the time period. And then from time period, take a reciprocal, you got the frequency. And one box is equals to 50 millisecond, means 50 exponent minus 3. So example, if we take for 2, so this is one box, two box, 3, 4, 5, and 6 boxes are there. If I'm taking, because it will be difficult for one, so if I take for, because when we take a larger values, it reduce the percentage uncertainty. So 1, 2, 3, 4, 5, and 6, approximately 6. Or if you take for these, this is also 2. How it is 2? Because from here, one peak to another, it's one wavelength, and this is also another. So it means there are two wavelengths are there. So if I measure this, like this is one box, two box, 3, 4, 5, 6, and about 6.5 or 6.4. So I have how many divisions are there? I have 6.5 divisions or 6.4 divisions. Approximation, because even you can see there are markings here on the axis. So 1, 2, 3, 4, 5. So if one box is divided into 5, so this will be about half of it is there. So if I took this as 6.4, and then this 6.4 multiplied by, because each box is 50 milliseconds, so it is 15 to the raised power minus 3. When we multiply, what we get 0.32 seconds. That is a time for 2, because we took one crest to another, and then we took 3 successive crests, so it's time period for 2. If we need time period, so time period will be 0.32 divided by 2, which is equals to 0.16 seconds. So time period is 0.16 second. If we need the frequency, frequency is reciprocal of the time period. So 1 divided by 0.16. So we get 6.25, and the unit will be hertz. Is it clear how we work out the frequency? So especially for unit 6, as you can see, you don't find these type of questions in the book, or even if you read any text, you don't find it. It's the best thing for preparation of unit 6 is doing the paper. Like you will learn the things from the paper itself when you're solving. Is it clear, this question? Okay. Then describe how the student could investigate how the frequency vary with the volume flow rate, like how F can vary with the volume flow rate. So we want to investigate these two factors. As you can see from the beginning, the volume flow rate depends on the height. So the volume flow rate itself will not change. It will only change if we change this height. So how a student can investigate the volume flow rate by how volume flow rate affects the frequency, like the number of oscillation or vibration of this wheel. So the two quantities which we are measuring here, we are measuring a frequency and we are measuring the height. So what student should do? So student should like first measure the volume flow rate for a certain height and the frequency, and then he should repeat the experiment with different values of the height and then plot the graph, because to know the relation we should always plot a graph. So what student should do? Student should record the height and frequency and calculate the volume flow rate. Then repeat the experiment. Then the student should repeat the experiment with different heights and at the last, because whenever you want to investigate how things changes or what is the relation, so then plot the graph between, because we want to find a relation between volume flow rate and frequency. So plot a graph between the frequency and the volume flow rate. So that's how it should be done. So simple answers are there, but it is based on your understanding, how you understand the question. So simple answers are there, especially for unit 6. A student disconnected the water tank and the oscilloscope from a flow device. The student placed a water flow device in a river to monitor the flow of the river water overnight. He connect the coil of the water flow device to a data logger. The data logger records the frequency of the pulses. Give two reasons why a data logger is an appropriate piece of equipment to use for this task. So like basically, okay, Taha, your question is why height is recorded? Because if you see the question, the beginning of the question, student is measuring the volume flow rate, and the only thing what he can do, he kept the depth of the water constant. The only thing he can adjust is the height. So means the volume flow rate, the volume of the water which is coming out depends on the height. If we reduce the height, the volume flow rate will decrease. If we increase the height, the volume flow rate will increase as well. So by changing the height, we can only change the volume flow rate. Also, this depth of the water in the tank also affect the volume flow rate, but that we cannot change. As they mentioned in the beginning, the depth of the water is kept constant, so it cannot be changed. Only thing which can be changed is the height. So if we want to find a relation between a volume flow rate and the frequency, we have to change the volume flow rate. So how we can change the volume flow rate? By changing the height. Is it clear, Taha? The student disconnected. So here, give two reasons why a data logger is appropriate piece of equipment to use for this task. Look, what is here? You have to list the advantages of the data logger. What are the advantages of a data logger? First thing, data logger, you can operate it remotely. Like you can monitor, like what you can do, it can record, data logger can record the measurement over a long period of a time. But if a person is there or observer is there, then he has to stay like overnight, means like 12 hours or 24 hours to do the experiment, which is impossible to do. The second thing, the data logger can record a large amount of data. So the points which will score marks here, one is it can be operated remotely and record large amount of data. So these are some advantages of the data logger. And even if a data logger is interfaced with a device, computer device, it can also plot the results. Question 2, this is Unit 6, those who just joined now, Unit 6 from 2023. As we'll discuss question or two from the every beginning of every session, we'll discuss question from Unit 6. I have sent the notes related to Unit 6. You can go through the notes. And Unit 6, you will only improve when you practice. So directly doing the question, as this Unit 6 for physics, it's not like only based on what is there in the planning experiment. It's based on your understanding throughout what you have studied about physics. So sometimes very basic structure, basic type of questions are also there in Unit 6. The absorption of the beta particles in aluminium can be investigated using an apparatus shown. We have a lead line box in aluminium sheet is there, a beta source, a gamma tube, and a rate meter is there. State 2 safety precautions for this investigation. Whenever you are handling a radioactive source, what are the safety precautions? You should always keep a safe distance from the source, and you should use a source with a for a short time, or use tongs as well, or the source should not point towards the body or the soft tissues. So whenever you are handling a radioactive source, use tongs, keep safe distance, and use it for short time. Only two are enough. A student planned to test whether the beta particles are absorbed by aluminium according to the relationship C equals C naught e raised to power minus mu x. So sometime in Unit 6, you will see some weird equations, but don't be confused with the equation. Usually, because there are many equations which you are not studying all of them. So sometime equation may not appear in your course outline, but in Unit 6, they can give you an ask question related to the equation, where C is the count rate when the thickness of aluminum sheet is X, C naught is the count rate with no aluminum sheet, and mu is the constant. Explain why a graph of LNC against X could be used to test the validity of the relationship. Now, what to do this, like because we want, basically we want to plot a graph between LNC and X. So remember, whenever you want to cancel out this exponential function E, you take ln. So we have C is equals to C naught e raised to power minus mu x. So what we will do, we'll take ln both sides. So this will be ln C is equals to ln C naught e raised to power mu x. Remember, when ln in a log, when two quantities are multiplied, how we write them? We write ln A plus ln B. When two quantities are multiplied, we write them as addition. When two quantities are divided, like if ln A divided by B was there, then we subtract, it will be ln A minus ln B. So because here two quantities are multiplied, like C naught and E function are multiplied, so we write them as addition. So ln C is equals to ln C naught plus ln e raised to power minus mu x. Remember, ln and e are anti-function, like they cancel out each other. So what is left if ln e raised to power a is there? So what we are left with, it will be equals to a. If ln e raised to power b is there, then it will be b. If ln e raised to power c is there, then it will be c. So if ln e raised to power c, so we'll left like what is left as a power, that like what is there the power of exponent that we are left with when we take ln. So this will be ln c naught, and ln and e cancel out. So and this is minus mu x, so this will be minus mu x. Now if we rearrange, because we want to plot a graph between ln c and x, so we want the equation to be y is equals to mx plus c. Like quantity which we are plotting on y-axis should be separate and the quantity on x-axis separate. So if I rearrange this equation, the equation will turn out to be ln c is equals to minus mu x plus ln c naught. And now when I compare with the equation of straight line, which is y is equals to mx plus c. So if on y-axis I have ln c, like on y-axis, I will plot ln c. On x-axis, I will plot the thickness, x. What will be the gradient? The gradient is equals to minus mu. And what is a y-intercept? It will be a positive y-intercept as it is ln c naught. So means, and mu is a constant value. So if it's a constant value, so gradient is constant, it means it must be a straight line. And because there is a positive y-intercept, so what will be the shape of the graph? The shape of the graph, it will be a straight line starting from above the origin or from y-axis. So how we can use this result? So when we first take ln both sides, and then when we plot a graph between ln c on y-axis and x on x-axis, then the gradient will be equals to minus u, and the y-intercept is equals to ln c naught. Is it clear how we use this equation to plot the graph? Then the next question, devise a plan to obtain the data required to test the validity of this relation. Look, for this relation, what we need ln c is equals to minus mu x plus ln c naught. This is a constant. So c, if you c is the count without sold, without the aluminium, and like without aluminium sheet, and c is the count with aluminium sheet, and x is the thickness. So this one is actually representing a thickness. This one is representing the counts without sheet, without aluminium sheet in front, and this is a count with aluminium sheet. So what are the things we have to measure? We have to measure the thickness, and how we can measure that is also important. So just looking at these quantities, so what we have to do, we have to measure the thickness x. What is the best apparatus if we want to measure a thickness accurately as possible? By using micrometer. And when you measure the thickness, you should always like repeat the experiment. So how you can repeat this experiment? So record the thickness from several places and take an average. So measure the thickness x by using micrometer and take several readings from different places, then take average. And always check for zero error. Whenever you're using a micrometer, don't forget to check for zero error. Then what we'll do, we'll record the count, which is a C naught there. So record the count rate. If you are recording with aluminum, so record the count rate. And when experiment is done in nuclear, it should be done for a longer period of a time, because so we can get a more accurate result. So record the count rate over a long period of a time. Then add or place aluminium with known thickness. Then record the counts again. And then repeat with minimum. You should repeat the experiment with 5 sets of thickness. So that's how this experiment should be done. And what are the things you should keep constant? Because we want to measure how the thickness of aluminum sheet is affecting the count rate. So we should keep the distance between the source and detector constant. That should not be changed. So you should keep the distance between the source and detector constant. That should not be changed. Rest, only thing, because the parameter we are investigating here, we are investigating how the thickness affects the count rate. So we should only change the thickness and record the counts. But the distance between the source and detector should be kept constant throughout the experiment. So this was question 2 from June 2023. So we did question 1 and 2. Next session, we'll do remaining questions from this paper.